Hello guys, so welcome back to my channel, and today we're going to solve some examples of um, the wave equation. We're going to pick a basic example and we're going to pick a bit challenging example. We're going to see how we're going to solve such equations when we are given one. So in the first example, we have UTT being equal to 4uxx. So we know that we can rewrite this as UTT minus 4uxx being equal to 0, and that is very simple because you know that anytime you have a wave equation like this, right, the solution u of xt, we know it's supposed to be a function of x minus ct. So what is c here? C, know that this is utt minus c squared uxx, right? So it means c is 2, so that's going to be 2t, then plus g of x plus 2t, right? So that's really simple to solve. But what if you are given a question like this? How do you solve it? Okay, so I'm gonna walk you through it. So the first thing you need to know is that this is where we're going to apply the classifications we know. Okay, so we first have to classify this PDE as either elliptic, parabolic, or hyperbolic. And if it is hyperbolic, then it means we can solve it as we solve the wave equation. Okay, so first of all, let's try and then classify this PDE. You know that our a11 here is going to be 1, a12 is going to be negative 3 over 2, a22 is going to be 2. Okay, yes, so you know that our delta is going to be a11 a22 minus a12 squared, which is going to be equal to 2 minus 9 over 4. That's going to be negative 1 over 4, which is less than 0. Hence, we have a hyperbolic PDE. Okay, so now that we know that it's hyperbolic, we can solve this just like we're solving the wave equation, right? So, what do we remember when we are solving the wave equation? If you remember correctly, there is always this difference of two squares. We convert the wave equation into a difference of two squares, and then we can write a solution straightforward. Okay, so that's the same thing we're going to apply here. So what we're going to do is to try and apply completion of squares here. So we're going to complete squares here, and this is how we're going to do it. First of all, I'm going to write the PDE in this form. Del x squared minus 3 del xy plus 2 del y squared, all multiplying u equals 0. Okay, so here is the trick. We're gonna have del x squared minus half the value. We are completing the squares with respect to the del x. Okay, so we're gonna have minus 3 over 2 del y, right? Because del xy, know that del xy is the same as del x del y. Keep that in mind. So that's what we are doing here. So the half value of the coefficient of del x is going to be 3 over 2 del y. All right, so that is going to be still multiplied by del x, so we're going to still have del x del y. Okay, then plus the square of the half value of the coefficient of del x, which is going to be 9 over 4 del y squared. Note, it is the coefficient of del x here. Okay, so put that in bracket, then plus, since we are adding this to the expression, you have to subtract that from the same expression. So you're going to have 2 del y squared minus 9 over 4 del y squared, all u equals 0, right? So now we know that this can be written as del x minus 3 over 2 del y all squared minus, when you try and simplify this, you're going to have if you simplify the entire thing, you're going to have minus 1 over 2 del y, all squared. Okay, so that's just some algebra you can do. Now we know that if we are able to write this in the form del maybe c squared minus del eta squared, u equals 0, we are done, right? Because this goes back straight to how we solved the how we solved the wave equation. Okay, and once we have that, we can just write the solution as a function of the x minus ct plus a function of the x plus ct. Okay, so once we have this, we should be done. So what we are going to do is that we are going to move from the xy coordinate to the Casey eta coordinate. Okay, so we want, let me write this, to move to the Casey eta coordinate such that del c squared minus del eta squared of u is going to be equal to 0. And once we have that, we are done. Okay, so pay attention. So how are we going to do it? So it means that we should have x and y as a linear combination of the Casey and etas. We don't know yet, so we are going to let x be a combination of the Casey and eta, which we don't know yet, so we are yet to find what a11 is and what a12 is. And y is also going to be a21 Casey plus a22 eta. Okay, we are going to look for this. Okay, now we know that del Casey is going to be equal to the derivative of u with respect to x, right, multiplying the derivative of x with respect to Casey. Okay, yes, then plus the derivative of u with respect to y times the derivative of y with respect to Casey, because we are trying to find the derivative of u with respect to Casey. Okay, by chain rule, that's it. So what do we know? We know that this is still going to be del x, fine, but what's going to be del x del Casey? We know x, we know y, so let me call this equation 1, this equation 2, this equation 3. Okay, from equation 2, del x del Casey is a11, right? That's okay, right? Then plus del y del Casey, what's that going to be? That is going to be a21, right? Yes, I'm taking my time so that you can absorb and assimilate whatever is going on. Now what of del u del eta? That's going to be del u del x del eta plus del u del y del eta. Okay, and that is going to still be del x del eta is going to be a12 similarly, and you're going to have del y del eta, that's going to be a22. Okay, so let me call this equation 4, this is equation 5. Okay, now from here, right, from equation 1, let me call this one star. Okay, if we compare equation 1 and equation star, we know that del c, or del u del c, this is the same as the entire thing here. Okay, so but we know that del c is equal to del x minus 3 over 2 del y, right? Right? So this implies that a11 is equal to 1 and a21 is equal to negative 3 over 2, right? Similarly, we know that, so let me do this, and del eta is going to be just this term here, and that is going to be 1/2 del y, right? Yeah, that's correct. So that from del eta, we know that a12 is going to be 0 because there is no del x here, and a22 is just going to be 1/2. So now we know all the coefficients. We know a11, we know a21, we know a12, we know a22. We can have the change of coordinates. We can have the linear combination of c and eta, which are going to give you your x and y. Okay, so this implies that x is equal to, from here, a11 is 1, so 1 times c is just going to be c, but a12 is 0, so it means x is equal to c. Similarly, y is going to be equal to a21 c. What is a21? That is 0. Oh, wait, what? No, a21 is negative 3 over 2, sorry, c plus a22, which is 1 over 2 eta, right? Okay, so now we know that our new PDE is the equation 1. So let's recall, let me write it once again. Recall that, del c squared minus del eta squared u is equal to 0, right? So that is our new wave equation. And once we have something like this, we know that the solution is going to be a function of c. So let me use a small letter, of c plus eta, then plus another function of c minus eta. We know this because we've done it already, right? Yes. But we are not interested in having our functions, or we're not interested in having solutions in the new coordinate system. We want our solution in the original coordinate system. So it means that we are going to need u of x, y, and that's going to be a function of what is eta. We know eta to be x, so we're going to have x plus cause c is x. What is going to be eta? Eta is going to be, from here, I'm going to have eta to be 2y plus 3x. If you want to know why I'm saying it's 2y plus 3x, this is why I'm saying it. It's actually going to be, eta is going to be, let me just try and then simplify. I'm simplifying this, right? So we're going to have y plus 3 over 2 cos c equals 1 over 2 eta. And then you're going to realize that eta is going to be 2y plus 3 cos c. But we already know that cos c is x. So that's why we have eta to be equal to 2y plus 3x. Okay? Yes. So this is going to be equal to 2y, x plus 2y plus 3x. Then plus the function g, eta x minus 2y minus 3x, right? And this is going to be a function of 4x plus 2y plus, oh, this is supposed to be a capital G of, you know, this is going to be minus 2x minus 2y, right? Yes, so if there are any common factors, you can just pull them all out and then have maybe a function u of xy being a function of, let's say, 2x plus y plus a function, let's say g, that's going to be, you know, x plus y. And this is the solution of the wave equation, okay, or of the equation that was given. All right, yes, so if you like the content of my video, please leave a like and subscribe to the channel. There are more to come. So see you guys in the next video. Bye bye.